In this video, we're going to be looking at the second half of lesson 9.2. And in this video, we'll focus on that second essential question, which is how do you apply the formula for the area of a regular polygon? In the previous lesson video, we talked about how to calculate the area and circumference of a circle. If you didn't get that part of your notes done, go back to the 9.2 day 1 video. Let's start with some vocabulary. First, a regular polygon is just a polygon where all the sides are equal and all the angles are congruent. The center of the regular polygon is a point that is equidistant from the vertices of a regular polygon. So when we talk about the vertices are just the corners of the shape. So F, G, H, D, E, those are my vertices. The apothem is a new word, and this word is going to be important for us. The apothem is the perpendicular distance from the center of a regular polygon to a side. So in our picture here, see how this dotted line, line BC or segment BC, goes from the center and it's perpendicular to a side of the polygon? That's the apothem. And then the central angle of a regular polygon is an angle whose vertex is the center of a circle or the center of a regular polygon. So we can kind of think of this like I could make a circle around here if I wanted to. So the center of the regular polygon is going to be the center of the circle that forms the polygon. I'm going to just take that away though, so that we can focus just on our pentagon here in my picture. So the central angle is this angle right here, angle DCH, but there are other central angles as well. For example, another central angle would be angle GCF. So there's 5 different central angles since there are 5 different vertices in my shape. To find the measure of the center angle, since a circle, like the full circle in the middle here, is 360, what you do is you just take 360 divided by n, and that's going to give you the central angle. So that's going to be an important formula here. If we need to figure out the central angle, we just take 360 and we divide it by the number of sides. So now that we have that vocabulary, let's go ahead and look at the formula for the area of a regular polygon. The formula to calculate the area of a regular polygon is area equals 1/2 AP, where the lowercase a stands for the apothem and the uppercase P stands for the perimeter of the polygon. If the perimeter of the polygon isn't given, you can calculate the perimeter by taking the number of sides times the side length, because in a regular polygon, all the sides are equal. So for example, this polygon has 6 sides. It's a hexagon. If each side is 8, I could figure out the perimeter by just taking the number of sides, 6, multiplying by 8, and we'd have a perimeter of 48. The apothem will often be given to you, but if the apothem is not given, then what you're going to do is you're going to use trigonometry. So this is going to be a review from one of the units that we did previously. And to use trigonometry, you first need to actually find the central angle. So the central angle can be found by taking 360 degrees and dividing that by the number of sides. So I need 360 divided by 8. There are 8 sides here. It's an octagon. So we would have 45 degrees. Now the 45 degrees is this value right here, the central angle. But when we do the apothem, we actually take that central angle and you divide it in half. See how it's like the central angle would be this big one right here, but we're chopping it in half when we get the triangle with the apothem. So I actually want to take half of 10, which is 5. So this is 5. And then I also need half of the 45 degree angle. So this angle right there, if I take 45 and I divide it by 2, it's 22.5. So that angle there is 22.5 degrees. Now we have enough information to figure out the apothem. We can use trigonometry. I'm going to just redraw that green triangle that's outlined there. I'm going to make it bigger so we can label it better. You don't need to do this in your notes. I'm just doing it for the video. You should be able to fit it in the box, hopefully. And that angle right there is 22.5 degrees. So now, if we use our trigonometry, remember that's your SOHCAHTOA, sine, cosine, tangent, we can label the sides. The hypotenuse is going to be across from the 90. The opposite is across from that 22.5 degree angle. And the adjacent is the last side left. Now, we only care about the adjacent side and the opposite side because those are the sides that we either know or we want to find. So the hypotenuse isn't really going to help us here. So I want to use tangent. Tangent uses opposite and adjacent. So we can write a tangent ratio by saying, well, the tangent of the angle measure, so tan 22.5, equals O over A. Tangent is opposite over adjacent. So I'm going to put the 5 over lowercase a. And now we can solve it using cross products. So I'm going to take A times tan 22.5. And that's going to equal the other cross product, 1 times 5, which is just 5. To solve for A, we need to divide out the tangent of 22.5. And when we do that, we can stick it into the calculator, and that'll be the apothem. So let's go ahead and look at an example here. In our first example, we're given a regular hexagon with a side length of 11.5 and an apothem of 10 centimeters. So this problem is nice because it's giving us the apothem. So let's draw that in our picture. The apothem is 10 centimeters, and then the side length is 11.5. And because it's a regular polygon, all the sides are the same. All sides are 11.5. All right, so let's write our formula down. The area of a regular polygon is found by taking 1/2 the apothem times the perimeter. We can calculate the perimeter by taking the number of sides, which in this picture we have 6 sides. It's a hexagon. So I'm going to take 6 times the side length. So I need 6 times 11.5. And if we calculate that, 6 times 11.5 is 69. So the perimeter is 69, the apothem is 10. Let's go ahead and plug those numbers in. So area equals 1/2 the apothem, 10, times the perimeter, which is 69. You can type this in your calculator all in one if you change the half to a 0.5. That's just going to be easier. So you can do like 0.5 times 10 times 69. And when you do that, you're going to get 345. So the area of our regular polygon here, the regular hexagon, is 345 square centimeters. For our final example here, I'm only giving you a side length and I'm not giving you the apothem. So we're going to have to figure out the apothem using trigonometry. Let's begin with what we know. We have a side length of 8. So all the sides are 8. And then the apothem, we don't know what it is. But remember that the apothem divides it in half. So if we take 8 and we divide it by 2, half of 8 is 4. So that's 4. And then I can figure out the angle if I start with my central angle. So the central angle is just 360 degrees divided by the number of sides. So I need 360 divided by 5, And when you do that, you get 72. So the central angle is 72. So that would be like this angle right here, 72 degrees. But for the one that's in the apothem triangle, the central angle is cut in half. So remember that we need to divide the central angle by 2 for the actual triangle that we're using here. So this is 36 degrees. And then the apothem I want to find is right there. Looking at just that triangle that's outlined in the green, you can label the sides in relationship to that 36-degree angle. The hypotenuse is across from the 90. The 4 is opposite. And the apothem there is the adjacent. Once again, we don't need the hypotenuse. We only care about the adjacent and the opposite. So we're going to use a tangent ratio. Tangent equals opposite over adjacent. So I'm going to go tan 36 equals 4 over A. And then if we do a quick cross product here, we would have A times tan 36 equals, and then 1 times 4 is just 4. To get the apothem, we're going to divide each side by the tangent of 36. And you can just type that in your calculator, and we're going to round to 3 decimal places, just so that we don't round too much too soon. So I'm going to keep 3 decimal places, and when I type this into my calculator, I am getting 5.5055. So that would round to, if I round up there, apothem equals 5.506. And it would be in inches. And now that we have that, we can find the area pretty easily, just like we did in the last problem. Area is 1/2 AP, or remember, I can also do A times P divided by 2. No, I do need to calculate the perimeter here. But the perimeter, if there are 5 sides, and each side is 8, 5 times 8 is 40. So let's replace the capital P with 40, and the A, we're going to use that number we just calculated. So I need 5.506 times 40. Multiply that on your calculator, and then divide by 2 at the end. So I'm going to type like the top in first, hit enter, and then divide the answer by 2. And when you do that, you are going to get 110.12. So if we round to the nearest tenth, 1 decimal position, we would say the area is 110.1, and it is inches squared. This is a great problem here. You're going to see one like this on your CYU, but just to make you feel a little better, there is not one of these on the test. It just takes too long to figure out the apothem by doing the trig. So you're going to see some of these on CYUs, but on the assessment that you'll take at the end of the unit, it's going to be more like example A, where it gives you the apothem, and you just have to calculate the perimeter and then do 1/2 A times P. So thanks for watching, and good luck as you try some polygons on your own. Bye.